This is the video tutorial for our Unit 3 homework packet. This is going to be pages 1 through 5. So if you need to skip ahead, just look at page 4, that's fine. But we're going to go over pages 1 through 5. So the first part here, we're talking about accuracy versus precision. I told my students the key to this is the second letter. So accurate is AC, and precise is PR. Okay? So something is accurate if it is C, correct, and precise if it is R, repeating. So when it asks you who made the most accurate measurements, it's asking you who's the most correct. The actual mass is 5.25. So if you look at it, okay, John was closer to 5.34. Brittany was pretty much, her answers were surrounded by 5.25, and Victor was kind of all over the place. So Brittany would be the most accurate. Her answers were the most correct. The most precise means repeating. So who is getting consistent results, or the same things over and over again? John got the same answer twice, okay, and this other answer is really, really close. So Brittany's answers were correct, but they were a lot more spread out, where she was well too high and pretty too low. So John was the most precise, and the least precise instrument means who used the worst scale, or the least precise scale, would be Victor. Okay, his scale only measured to ones units. He estimated the tenths. Brittany and John, theirs measured to the tenths place. So this one should be Victor. Alright, when you're looking down here at these types of problems, your types of waves are these 7. Radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, gamma rays. Those are your answers. So the greatest wavelength would be, it's showing you this way. There's a long wavelength. So greatest frequency is the opposite of wavelength. So if you have a long wavelength, you would have a low frequency. If you have a short wavelength, it's a small wavelength, then you would have a high frequency. Okay? So it's exactly opposite. If this is high wavelength, that means this one's high frequency. And energy, I like to tell my students to think of energy as being dangerous. If you have a lot of energy, you have enough energy to break DNA. So just by looking at it, you can guess which type of ray, or I suppose which type of radiation has the greatest energy. Alright, that was mostly day 1. This is down here for what my classes did in day 2. The wording on these rules, y'all, the wording on these rules are going to be word for word on your periodic tables. So you will get those 4 rules just like that on every test. So we need to learn what they say. Non-zero digits and zeros between non-zero digits are always significant. So I taught my students, anytime you see a number that is not a 0, it needs to be underlined like this. So if we skip down here to rule 1, 3 and 4, neither of them are zeros, so they both get underlined, which means they're both significant. So there's 2 significant figures in 34. 304, I'm going to underline again 3 and 4, because they're not zeros. Then what about the 0 in the middle? This says zeros between non-zero digits are always significant. So that means sandwiched. This 0 is sandwiched between 2 things I underlined. So that would make it significant as well. So that'd be 3. For these ones, none of them are zeros. So that means all of them are significant. 1, 2, 3, 4, 5, 6. Here, this last one, let's look at E. If I underline things that aren't zeros, and then I go back and underline anything in between those lines, that would be everything. So I'd count them all up. How many are there? That would be your answer. Rule number 2 says leading zeros are not significant. So I told my students, anything in front of my first underline does not count. Okay? So if I'm going to come through on rule 2 and underline anything that's not a 0. Okay? So if I come through like that, anything in front of the first underline, so in front of this, that's the first thing I underlined, right? Any zeros in front of them are not significant. So none of those zeros count. Okay? Students sometimes struggle with this, and they think leading zeros means zeros that are leading the decimal point. It's not leading a decimal point. This would be leading the first thing that I underlined. So then how many things are underlined? That would just be 1, 1, 1, 2, 3 things that are underlined here, because none of those zeros count as significant. Alright, looking down here at rule 3. Zeros to the right, which means at the end. So zeros at the end of non-zeros, which I underline, are only significant if there's a decimal point. Okay? So looking here, I underline anything that's not a zero. I don't have any sandwiched zeros. I don't have any leading zeros. Okay? Okay, so I underline the 1. There's no zeros in front of it, but there is a 0 after it. So this is zeros to the right of a non-zero digit. So rule number 3 means anything after the last thing I underlined will be significant if there's a decimal point. So here, there's no decimal point. So that 0 doesn't count as significant. So it would just be 1 sig fig. For this one, I'm going to underline the 1 because it's not a 0. And then I have numbers at the end of it. Numbers to the right, zeros to the right of it, are significant if there's a decimal. So because there's a decimal point there, they count this time. So I taught my students, we're telling the truth about the precision of our measurement. So if I did this number, and I was reading this scientifically, it says, 10. Alright, it means I didn't use a great scale. It's about 10 grams. When I use a decimal point and it's 10.0, I am saying, it's 10. I know it's 10. I used a good scale. So having 3 significant figures here tells me that I used a very accurate scale where I know it weighs exactly 10 grams. Here I might have just weighed it in my hand and been like, feels like about 10 grams. It's 10. So if I look at M, when it says that's a wussy number. There's no decimal point. So it's like, it's like 100 grams. It's 100, right? With no decimal point, that means I guessed those numbers. I'm not sure. So they don't count as significant. It's only 1 sig fig. Here, instead of saying, it's 100, I'm saying, it's 100, guys. It's 100. There's a decimal point. So those zeros count as significant. And that means 1, 2, 3, 4, 5 sig figs. We are sure. I am precise here. I know those are all significant. Here, I'm guessing. I'm not precise. So for this one combines a couple. So O is a great one to look at. I underline anything that's not a 0. Alright, there's no sandwiched, so I'm done with rule 1. Rule 2 says anything leading is not significant. So anything in front of what I've already underlined is not significant. 0's at the right of my non-zero. So anything after my last underlined is significant if there's a decimal, which there is a decimal hidden right there. So that would be 2 significant figures. Alright, it's a little bit goofy. You'll get the hang of this. Sig figs are really important for the rest of the year in chemistry and for all year in physics as well. Looking at rule 4, it says values written in scientific notation, which means times 10 to the something, like this. The digits and the coefficient are significant, which means I can come through like this and say times 10 to the 6th doesn't matter. Times 10 to the 9th doesn't matter. Times 10 to the 2nd. Times 10 to the 5th. Times 10 to the 3rd. Those numbers don't matter. Only my coefficients, which are these numbers out front. Only those ones matter. So I would come through, and I'm just going to look at U with you. Okay? Where 7, 2, 1. They're not zeros, so they get underlined. They're automatically significant. Then I have to use my rules for the zeros. The 0 is at the end. It's after my last underlined, and there's a decimal shown, so it would be significant. 1, 2, 3, 4 sig figs. Times 10 to the 9th means a bunch of zeros at the end, which don't count because there's no decimal. Alright. Page 2 and page 2 is more of the same. There is something I want to point out. I'm going to come through right here on X where it says times 108. I'm going to white that out. This should say times 10 to the 8th. And for this one down here, BB, make that one to the 8th as well. Those are just little typos. Okay. So here they're sticking all the rules together. Again, there are those rules written just like we talked about on the other side. So let's pick a few of these to look at. Okay. We'll do K, L, M, and N. We'll look at those ones together because we didn't do them in class with my students. I'm going to underline anything that is not a 0. So 8 and 4, for sure, those are significant. Then the zeros are trickier. This 0 is sandwiched. Okay, zeros in between are always significant. So, since it's between 2 underlines, it's automatically underlined. So that would be 1, 2, 3 sig figs. And then I've got a 0 at the end. 0 at the right. Zeros at the right are significant if there's a decimal point. There's no decimal point, so that doesn't count. This one would be 3 sig figs. For L, I underline anything that is not a 0. I have zeros in front, so leading zeros are not significant. Anything in front of my underlined, not in front of the decimal, anything in front of my underlined, which is why you should underline, is not significant. Okay, then I have zeros at the end. Zeros to the right, again, not to the right of the decimals, but to the right of what I underlined, are significant because there's a decimal point showing. So 1, 2, 3 significant figures for this one as well. 6, 9, and 9 are automatically significant. There's a decimal, so my 0 at the end is as well. There's 4 times 10 to the second. I don't worry about that for sig figs. 2.000. The 2 is automatically significant. All of these zeros to the right are significant if there's a decimal, and there is. So that would be 4 as well. Alright. Down here at the bottom, more practice. And it seems really, really redundant, but you'll get very fast at this, and it won't take you very long. You need to get quick at this. Okay? If we turn over, here we're rounding now to 3 significant figures. So we're going to find the first 3 numbers that count according to those rules we use, and we're going to round after those numbers. So here, all of them are significant because they're all non-zeros. So I'm going to go 1, 2, 3. And then I use this little shape like this. Okay, I use that to help me decide where I'm rounding. So I underlined the 7. 7's the one that's either going to stay the same or go up, depending on what's directly after it. So I had a student say 0 through 4, stay on the floor. 5 through 9, move up the line. I'd never heard that before, but she told me today. So because this is 5 through 9 and 8, I'm going to move it up the line and round that one up to an 8. 3.48. Okay. Let's come down here and look at 36. Zeros in front are never significant. So when I'm saying to 3 sig figs, I would go 1, 2, 3 like this. So that's where I'm rounding it. Okay. 0.0027, and because there's a 4 after it, I'm going to leave it as a 4. 1 through 4 stay on the floor, she said. It's kind of goofy, but it works. If we get to a problem like number 42, we're going to go significant figures for number 32. Okay, so if we're looking at significant figures for 42, we would say 1, 2, 3. There are my first 3 significant figures. So because this is a 5, I'm going to round this one up to a 10 and put a 0, 1. So I've got 2, 1, 0. I had a lot of people just putting that, though, 210. This is 20,000. So 210 is magically changing it. It's not rounding it. The answer should be very, very close to 20,950. So I can add zeros after it like this. 21,000. Okay? Like this. Except here's the problem. That's only 2 sig figs. So you have to move this to scientific notation by going 1, 2, 3, 4. 2.10 times 10 to the 4th. Alright. Go ahead and turn over to page 4. Page 4 is when we're getting into the math of it. So page 4 is really, really important. Every time you ever calculate something in chemistry or physics, you have to put your answer in proper significant figures. You have to do your sig figs. So what we're going to do is I'm going to put this in my calculator. Okay? So here's my calculator. 0.030 times 20.0 equals 0.6. So I'm going to write that down here. 0.6. That's my calculator answer, but that does not mean it's my right answer. Okay. Now I have to find how many sig figs were in each of my problems, each of my numbers from the problem. So I'm going to underline the 3. Anything in front of what I underlined doesn't count. My number behind it does count because there's a decimal point. So I have 2 significant figures in that number. Here, my 2 counts as significant because there's a decimal. These ones here at the end count as significant. So I have 3 significant figures. So the rule with multiplying or dividing with sig figs is you go for the smallest number of sig figs. Okay? So we're going to go ahead and grab the smallest number of sig figs. So 2 or 3, the smaller number is 2. So my final answer needs 2 sig figs. Right now, my calculator only gives me one significant figure. That 0 doesn't count. So I put 0.60. Okay? So what this says is about 0.6. This says exactly 0.6 because I'm sure of this number to 2 significant figures. I'm sure of this number to 3 significant figures, but it got watered down by something I'm not as sure of. So my final answer needs 2 sig figs like that. Okay. If we're coming in and looking at this one, 420 divided by 1.0, okay, is 420 in the calculator. Obviously, 420 divided by 1. But it matters that it's 1.0 because that's 2 sig figs. 420 is also 2 sig figs, so my answer needs 2 sig figs, 420. Okay? If I did 420 divided by 1 like this, then I would have to round that number to 400. But because it's 1.0, I'd say 420. Alright, let's skip down here to F, 3 times 25. Again, I feel like a lot of you in your head are like, yeah, it's 75. 3 times 25. Yeah, it is. But that's not the right precision. Okay? So what this says right now is 3 and 25. But I'm not very sure about those numbers because it's not 3.0. I'm saying 3. I'm not saying 3.00. It's 3 for sure. Okay? So this is one significant figure times 2 significant figures. I need to go to the smallest number of sig figs, so right there. My answer can only have one significant figure. So I would have to go like this and round it. The 5 makes the 7 round up to an 8. 80 with no decimal point has 1 sig fig. So I'm not sure enough of these numbers to say 75. I have to estimate and say, well, because I'm not sure of this number, I have to go to 80. We'll get lots of practice with this. Good gracious, one of the last things. I feel like this tutorial is dragging on for me, so I know you are feeling that way too. I hope you're skipping to what you need. What we've got for this one, standard notation versus scientific notation. Scientific notation is a fantastic way to put a giant number into manageable form. And we're going to get to times 10 to the 22nd in some of our numbers throughout this school year. Or to take a teeny, 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 tiny negative 11th number and make it more manageable. So I told my students, if you were drawing a cloud, right, in elementary school, we would have your sun and your cloud like this. Okay, so we're going to be doing lots of little bubbles like this one. For real, draw the bubbles. Don't be proud. So 10 to the 7th, if you're going to put this in your calculator, okay, I would go 10 to the 7th equals 10 million. You don't need to really put that in your calculator. But what this problem says is 7 times 10 million is what this is saying. Okay, 10 to the 7th is 10 million. Really what this means is a huge dang number. So if I'm taking something times an enormous number, it's getting bigger, which means I need to add zeros after it. So I'm going to put 7 here. Right now I have an invisible decimal point right there, and I can stick it in there. So that invisible decimal point is right here, right now. Alright, so we've got our invisible decimal point here. What this says is I moved it over 7 times. So I'm going to draw a bubble. 1, 2, 3, 4, 5, 6, 7. That's where the new decimal point is going. So I can come over the top and add in zeros now, wherever I had those little bubbles. Okay? So I'm going to go 1, 2, 3 like this. 1, 2, 3. You have to put in your commas. So that's 70 million. Okay? This is the same thing as 70 million. If we come down here and we're looking at number 3, 8 times 10 to the 8th. This is a big number. 8, positive 8. So I need to add zeros after. 8, my decimal point's here right now. I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8 times. And then add zeros in over my bubbles. So comma here, that's 800 million. When you come to a number like this on number 8, this is to the negative 10th. So because this number is less than 1, this number is going to end up being less than 1. It's going to be a decimal, like this one up here, 0.000. This number is less than 1. So when this number is less than 1, this number will be. So 8.34 is what we have now. The way for me to make this number smaller is by adding zeros in front of it. So I'm going to move it over 10 times this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy cow. 0.00000000834. Good heavens. That's why we write it like this, so it's not all those zeros. But it's the same thing. This number is very, very, very small. It's much less than 1. Negative 10 is less than 1. So that's how we knew that I was moving the decimal point this way. So the number got smaller. The opposite of this process is on page 5. Okay. Here they're giving you the full number you're putting into scientific. So we have to move the decimal points so that there's only one non-zero number in front of it. Okay. So here they're showing you they moved it right there, 3 points. So this is where we're going to put our decimal. 6 point, 4 point, 6.1, 2.7, 2.1. We're going to move our decimal points like that. So let's look at this one. I'm going to change it so that it says 2.1. I'm going to leave off all the extra zeros at the end because they're not significant. How do I know they're not significant? Because zeros at the end are never significant if there's no decimal. So none of those zeros actually matter. I can cut them off. So I'm going to take my invisible decimal point here and move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So 2.1 times 10 to the, I move the decimal point 11 times. Okay, I bubbled over 11. That's how this number is 11. Number 8. This number is less than 1.000000679. It's much less than 1. So my exponent will have to be less than 1. My exponent will be negative. Okay? So I need to move the decimal point here so that it's 6.79. I get one number in front of the decimal point that's not a 0. In order to do that, I move my decimal point 1, 2, 3, 4, 5, 6 times. So I moved it 6 times. And it's negative 6. It's less than 1, a negative number, because this is less than 1. Okay. I'm not going to do a video tutorial for the rewind bonus. I told my classes this was extra credit, 5 points of extra credit. Here you're doing Unit 1, but you're doing it in proper sig figs. We did this on our after-test activity, the worksheet after your last test. I'm going to go ahead and do this. If you already have these answers, you can skip this part of the tutorial. If you were absent, you're going to want to look at this. Okay. But anytime I'm multiplying, okay, if you turn that multiply sign, so watch. Now it looks like a plus sign. Okay, it looks like a plus sign. Or I'm going to turn it back. It's multiply. So if I rotate my multiplication, it becomes a plus. And really, it doesn't take much imagination to see that divide looks like negative or subtract. Okay. So when you have numbers in scientific notation, don't put it in your calculator. This is a huge mess. So I'm going to take my numbers out front, those coefficients, and I'm going to do what the math tells me to. I'm going to ignore the times 10 to the whatever for now. So my math tells me to multiply 2.2 times 3. So I'm going to stick that in my calculator. 2.2 times 3 equals 6.6. 6.6 times 10 to the, and then I'm going to multiply those numbers and add these numbers. So I'm going to take my exponents and add them together. So 3 plus 8 is 11. Okay. When you're doing these ones down here, you're going to divide these numbers, this number divided by this number, and then for the exponents you subtract. Negative 2 minus negative 6. You should get real fast at these. I know that if you're absent, a video tutorial is not enough, so please come in for extra tutorial help. Really, 5 minutes one-on-one with the teacher, you'll get really quick at this. Alright, good job, y'all.